Hello Chem 1A, this is Chapter 3, Lecture Video 7, and in this video we're going to be talking about how mass and the mole relate to each other. So this is known as molar mass. Molar mass is defined as the mass of 1 mole of a substance, all right, in grams. So for instance, if I have 6.022 times 10 to the 23 atoms of, carbon, then how many grams is that? That number would be my molar mass. So how do we calculate molar mass? Well, for elements like carbon, we don't. We look it up. The molar mass is actually numerically equal to the atomic weight. So in other words, if we look at the periodic table, carbon's atomic weight is 12.01 AMU. We can say that this is 12.01 grams per mole, and this is my molar mass of carbon. So from now on, we probably won't be referencing the numbers in the periodic table as atomic mass anymore. We'll just call it molar mass because that is the one we use primarily, by far the most. Now, like I said, what this means is that the molar mass is effectively the same value that we find in the periodic table square for each element. However, we do need to calculate molar masses of compounds. Compounds have different molar masses than the elements that make them up. And how do we calculate the molar mass of a compound? Well, it's pretty simple. We take the molar mass of all the elements in the compound and we add them all together. So let's do some molar mass calculations for these two compounds, right? So I have copper 2 bromate. So I'm first going to start by saying, hey, that's copper 2 plus, and bromate is BrO3 minus. This compound is CuBrO3 2. Now the first thing I probably want to do is I want to figure out how many of each element are present in the compound, right? I know there's 1 copper, there are 2 Brs, there are 6 oxygens. And I need to look up the molar masses of each one of these elements. If I do that, I get 63.55 grams per mole for copper. Again, I'm just looking these values up off the periodic table. Br is 79.90 grams per mole, and oxygen is 16.00 grams per mole. Now, if I want to calculate this guy's molar mass, I just need to multiply these molar masses by the number of each element and then add it all together. And if I do that, I get the molar mass of copper 2 bromate is 319.35 grams per mole. Okay, so let's do this one more time. Now we're going to do it with disulfur tetrachloride. So disulfur tetrachloride should be S2Cl4. Sorry, not 5, that's penta. 4. So again, we have 2 sulfurs, 2 chlorines. We need to look up these molar masses. Sulfur's molar mass is 32.07 grams per mole. And chlorine's molar mass is 35.45 grams per mole. Now I have 2 sulfurs, so I need to multiply sulfur's molar mass by 2. And I have 4 chlorines, so I need to multiply that by 4. And then I just need to add these together. This will give me a molar mass of about 205.94 grams per mole. Okay, so now that we've learned how to determine the molar mass of a compound and an element, we can move on to what do we use Avogadro's number for, and what do we use molar masses for when we're doing calculations. So mole and mass conversions, molar mass, what it allows us to do is convert between the mass of a substance and the moles of a substance. Typically, we don't measure moles directly. We measure the grams because we have a mass balance, and we need to be able to convert from grams to moles. That's what molar mass allows us to do. We also might need to do the opposite, go from moles back to grams. So that's what it really does for us. Now, how do we do that? If I have moles of a substance and I multiply by molar mass, which is in units of grams over moles, you can see that the moles will cancel. We'll be left with grams. So effectively, I take moles and I multiply by molar mass, to get grams. If I have grams and I want moles, then I need to put grams in the denominator, moles in the numerator, which is effectively the inverse of molar mass. In other words, if I take grams and I divide by the molar mass, I'm going to get moles. All right, so for instance, let's say I have 16.5 grams of carbon. I look up the molar mass of carbon, it's 12.01 directly from the periodic table. I can calculate how many moles there are of carbon atoms by just dividing by the molar mass. This gives me 1.37 moles of carbon. Now, let's talk about Avogadro's number as a unit factor. So 6.022 times 1023 is how many particles are in 1 mole. So maybe I have 2.35 moles of carbon atoms. And now I want to find out, hey, how many atoms is that? Well, I can do that using Avogadro's number, right? So 2.35 moles. I know that in 1 mole of anything, there are 6.022 times 10 to the 23 things, in this case, atoms. And if I multiply these out, I get how many atoms there are in 2.35 moles of carbon. And that would be 1.42 times 10 to the 24 atoms. If I wanted to, I could go from atoms back to moles and then use molar mass to get to grams, or vice versa. So I'm going to show you a little bit of a picture image to demonstrate that. So here's a good infographic to show how to do this, right? So if I have mass and I want to get to moles, well, then I got to divide by molar mass. If I then want to get from moles to particles, I multiply by Avogadro's number, right? So if I want to go from particles, let's say I know how many particles there are, I need to divide by Avogadro's number to get to moles, and then I need to multiply by molar mass to get to mass if I want to. These two factors, molar mass and Avogadro's number, often work together to kind of go from one thing to another thing. Grams to moles to particles. All right, so let's talk about relationships between atoms and the compounds and the molecular formula. So if we want to do a mole calculation from the substance, let's say calcium chloride, which we know is CaCl2, to an atom within this substance, right, like Cl or Ca, then we need to be able to come up with what we call a mole ratio. Mole ratios allow us to convert from the compound to one of the atoms within the compound. Now, in this compound here, we know that there is 1 calcium and 2 chlorine atoms in each calcium chloride formula unit. Now, if I have 56.43 grams of calcium chloride and I want to know how many atoms there are in that sample, I need to use this relationship of 2 to 1 to do that. Because I have grams of the compound, I don't necessarily have grams of Cl. So let's do this, right? So we have 56.43 grams of CaCl2. The first thing I need to do is I need to calculate the molar mass of calcium chloride, which in this case, if we do calculate it, you should get about 110.98 grams of CaCl2 per 1 mole of CaCl2. And I strongly encourage you to continue labeling your substance, because we're now going to switch from moles of calcium chloride to moles of chlorine in this case. I know that in every 1 calcium chloride, there are 2 chlorines. So in other words, in every 1 mole of CaCl2, there are 2 moles of Cl. So if we're following along, right, I've canceled grams of calcium chloride. I've canceled moles of calcium chloride. I'm now in moles of chlorine, and I want to get how many atoms of chlorine there are. Well, I can do this now using Avogadro's number. I know that 1 mole of chlorine is 6.022 times 10 to the 23 atoms of Cl. And here now I'm canceling my moles of Cl, and I'm left with atoms of Cl, which is what I was asked for. I can now calculate this, and I get 6.12 times 10 to the 23 atoms of Cl. All right, so if you have any questions at all, please don't hesitate to ask. I'm always happy to help. These problems, definitely, I can't do every single example possible. So there's a lot more variation here than just these example problems.